everyone. Thanks for having me here. Paul, I still hate you. So today I'm going to talk to you about Moqups. So what is Moqups? Moqups is an online app that helps you get your ideas out of your head really, really fast. So you can produce crisp mockups and wireframes and interactive prototypes really, really easily, even if you have no technical skills or any kind of design skills. It kind of looks like this. This is the last release. I'm going to talk to you about it later. So how it all started. So back in 2010, by the end of 2010, our startup closed its doors, and the team in there decided that, including me, decided that we should build a product, another product that would eventually bring us back together. So we explored many ideas like iOS apps, and there was this gold rush with iPhone by then and so on. And we noticed that it was really frustrating to get feedback on our ideas and to sketch them out really easily. So in one night we decided that, hey, why don't we build mockup tool so we can generate more ideas faster, and it will also solve that problem where what should we build next. So we founded the company in 2011, and we developed most of the product in our spare time. And after a lot of times being lazy and not doing anything, we've managed to launch a beta in 2012. And encouraged by our success, we decided to monetize in 2013. So eventually in 2013, by the end, a few months after we've launched the premium version, we've been able to employ ourselves at our own company. Yeah, so where are we now? Remember, this is a niche app. It's not a very, it's not Facebook. It's not a consumer product. So we are at 500,000 users. We have more than 12,000 paying customers, and we're still completely self-funded. We didn't took any funding so far. That means we're not using Bootstrap. Yeah, and we've recently grown to 16 employees, including ourselves. And more importantly for us, we've managed to launch Moqups 2, which is basically, it turns a basic design tool into an advanced design tool. And that's happening on the web. So when we started, before we started the app, we made an exercise of imagination and said, how would the ideal wireframing and mockup app look like? So first of all, it should be really, really fast. Nothing should stay in the way of your creativity. So no lagging, no preloading, not too much preloading. It should be really easy to use for the very same reasons. And it should provide a desktop-like experience as much as possible. So, and more than this, like the previous presenter said, it should produce crisp-looking graphics that would scale infinitely, especially with this Retina display and high DPI displays. And it should use no plugins. Steve Jobs just killed the plugins a few years before, so no plugins. So the initial set of features was kind of basic, but it was numerous. So we had to handle a lot of moving parts. We had undo, redo, we had arrange, align, images, upload, and it sounds like a lot for a minimum viable product, but you cannot live without this in a basic graphical editor. So we had to do this. Undo, redo, a bit of interactivity, export to PNG, PDF, and so forth. So we had a lot of moving parts from the beginning, but we also had a lot of unanswered questions. So we decided that before we even start coding on the app, we should build a prototype. the most recurring questions were, how do we actually draw 2D graphics on screen? So how do we export stuff to PNG and PDF? What framework are we going to use? This is probably the most fun part of any project. After that, everything goes bananas. And how do we compose the widgets? Because we knew it's going to be a mock-up app, so we had to have some sort of layout in place. And we started doing the comparisons and the prototypes with it. So we started the endless debate: is it SVG or is it Canvas? So SVG has a couple of advantages over Canvas. One, it's zoomable, scalable. You've seen the previous presentation. No matter how much you zoom it keeps the quality without any distortion. So if you look on a Retina display, it's the same thing as on a low-resolution display. It's got very nice support for grouping, and it's not only for containing stuff together, but also for chaining transformation. So you can do rotation, you can do translation at the same time, you can do scaling and skewing. So this is really powerful. It's something you don't have in Canvas, or you have to re-implement sort of by hand. It's DOM-based, and like the previous presenter said, designers can already produce content for it without programming anything, which is really nice. And it's got a powerful 2D graphics API. You have Bezier paths, you have masks, you have all sorts of stuff. Except perhaps 3D. But it also has there's no ideal solution. It has no support for multi-line text and word wrapping. Same as previous presenter. The previous presenter outlined the text in Illustrator, and it's actually vectorial. It's not actually text. It's SVG shapes converted from text. And that's for very good reason. SVG has really poor support for text, and not only for not only the lack of word wrapping, but also it's really poor in terms of displaying text. So Firefox, Gecko-based browsers were producing really bad display of text. By then, I don't know by now, because we're not using it. And back in 2011, it was kind of a dying technology. Nobody was using SVG anymore, except a few mad scientists in universities and a few giants like Apple for their Keynote and Google for their Google Draw application online. So this kind of gave us courage to, we said, if these guys are crazy enough to do it, we'll be crazy enough to do it. So we also evaluated Canvas. It's also got a very powerful 2D API. It's fast, it's hardware accelerated, and you get raw access to pixel data, which means you can do all sorts of crazy stuff as long as you know math. I don't, I hate it. And it tends to have less browser quirks compared to SVG because it's simpler, so it's not as prone to inconsistencies across browsers. And compared to SVG, the performance does not, there was this question in the room, performance does not degrade with the complexity of the document. So in SVG, once you have 100,000 of elements, you cannot avoid some performance degradation. You have to resort to all kind of tricks, like tiling and so forth, so to maintain performance. But Canvas doesn't care what you draw in the canvas. It's very, very fast, but it also has a lot of disadvantages compared to SVG. So first of all, basic stuff like heat testing, you have to reinvent the wheel for detecting where a click was performed, when the mouse is hovering something, and make sure you repaint the proper things. Zooming, you lose that. You have to repaint everything manually, calculate the scale factors and rounding and so forth. Grouping, you lose the chain transformation. You have to handle all the objects you display on screen in memory, which can be very buggy if you're not a very disciplined coder like me. And same as SVG, it has really bad support for typography, unless you build your own font rendering engine, which is not a good idea. I'll tell you why soon. And once you render on canvas, it stays like this. You lose quality, so you have to render at very high resolution, and the file size can turn quite big. So eventually, we're a very lazy team. We don't like working in general. We just like having fun. So we decided to be lazy and keep it simple, and we decided to stick with SVG. But we still had that problem with multi-line text. We could not outline the fonts, and we also wanted that the text is resizable in real time, so you could see instant feedback of your resize operation. So we were still naive by then. We're not anymore. And we decided to build a prototype from scratch, a prototype that would word wrap and realign everything together. And the plan was really simple, this naive. You would split a string into words, you would convert everything into a tspan element. Tspan is like a span in HTML, but it's positioned absolutely, in an absolute way. We would measure each text chunk, and we would position it according to the width and height of the container and so forth. It's not a daunting task. We implemented a prototype in 2 weeks. But we failed really badly, and this was probably the first existential threat to our new product. So after building a prototype, we realized that no matter what you do, even if you use web workers or whatever, which were still in their infancy in 2011, you would have performance degradation after no more than 300 words. Measuring how big a word is in terms of width and height turned out to be really difficult, and unreliable, especially for Firefox. And because Firefox cannot render stuff that didn't display on screen yet. So you'd have to display it, and displaying a DOM element means performance hit. And it turns out that typography is not really a simple science. You have ligatures, you have right to left script like Jewish and Arabic. You have different meaning for what a word is, and punctuation rules and hyphenation and so forth. So we realized it's a battle we cannot win. So we said, what the hell, roadblock, we cannot. We didn't want to sacrifice the typography support in Moqups. We said that if we don't have proper typography, then we don't build the product. So after more research, we found out about the foreign object tag. It's a very interesting tag that you can place inside SVG. So you can place any kind of arbitrary HTML or markup language, MathML or MusicML, whatever. And it inherits the container scale and rotation, which means if the group is rotated or scaled, it behaves like it's SVG. Your users will not know. But the problem with it is, like the previous presenter said, if you can take SVG out of Illustrator, and if you stay pure with SVG, you can import it back. So you can reuse whatever you produce in Moqups inside Illustrator. But with foreign object not being supported in these tools, you would lose the text. But we said, so it kind of looks like this. But we said that the text we have to place inside the foreign objects is quite simple. So in the future, maybe we'll find a converter that converts bold italics and simple text into raw SVG. And SVG2 promises to solve this problem by having the text flow tag, so you can have word wrapping and so forth. So we decided to keep it simple and not allow very complex HTML inside SVG, but we still had one problem. It was not supported by Internet Explorer. And Internet Explorer was still a giant by then. So we were still lazy again. We said, let's wait until IE dies. And it turns out that it was a good wait, because our customers didn't care too much about IE. We only had like 3 or 4 inquiries, and mostly not from the customers themselves, but from their clients saying they cannot view Internet Explorer, and we said just export it to PNG and PDF so they can view it. It's fine. So we decided that we would not complicate our lives with SVG, with IE, and it turns out that in 2015, fast forward, we're still in 2011, I guess. Internet Explorer is declared dead except IE 11, and Microsoft would focus all their efforts on the new Internet Explorer, Edge. And it turns out that Edge has really, really good support for SVG and also foreign object. So too bad we're not giving it any attention. Everybody in the office is using Macs, so it's hard to convince any lazy developer to install a virtual machine. So we still don't support Edge, even if it works. Yeah, so back to the past. Another fundamental question we had was, how do we export stuff? Because we wanted that people can export SVGs to PNG and vector-based PDFs, which would retain interactivity if you had a hotspot defined. So we looked at two possibilities. One is either do it with Canvas. There's this interesting function in Canvas called draw window. Basically allows you to draw the contents of HTML inside Canvas and then get a data URL out of it, a blob, which you can upload later on. And there are some server-side tools like PhantomJS and WKHTML, whatever. Or even use Chromium that's installed server-side. So we did a comparison. So Canvas, it's good for PNG, but you have cross-browser rasterization issues with this function. So for instance, Gecko, which means Firefox, would render the contents of an element like it's a different browser, a very old browser, crappy anti-alias support and so on. And there are a lot of security restrictions around this, mostly because the browser have to make sure your JavaScript cannot steal the contents of the page and steal private data. So they will restrict a lot what you can print on the canvas. So you'd have to deal with cross-origin issues and canvas getting tainted. And once a canvas is tainted, you cannot export it anymore. So there's also no PDF support. So somebody mentioned PhantomJS in another presentation. Yeah, so back then, the only kind of reliable tool for doing this, for exporting, was PhantomJS. It's WebKit-based, it's scriptable, and the PDFs resulted were very nice because they would retain scalability. They would still be vectors, so nice for printing, and nice for carrying your project to your customers, like a handoff. And it could also run headless, which means you don't need any X environment or virtual display. But it also has a lot of downsides. So it's very memory hungry. It has a lot of memory leaks, and it crashes for whatever reason. So we have, on our servers, we have cron jobs that would restart PhantomJS every couple of hours, just for no reason. And it has a lot of rendering quirks. So if you would have opacity on some elements, that particular area would render as a raster and not as a vector, and it would be a raster at very low resolution. it would consider its not print resolution, but web resolution. So we had to work around this issue quite a lot. So there's no ideal solution in these things. And it was also unable to retain interactivity for PDFs, because PDFs, we wanted that PDFs behaves as the small prototypes you can produce with SVG, so you can click something and go to the next page and so forth. So one of my colleagues was courageous enough to hack PhantomJS in a weekend and add support for PDF links inside. I don't know how he did that, and I don't want to know. Yeah, so the most fun question when you start a project is not business model, it's not how we're going to make money. If you're a programmer, it's what framework are we going to use? So remember then that in 2011 there's not so much wisdom that we have today. So there was Dojo, there was jQuery, Angular was ramping up by then, Sprout Core, yeah, I was sure you're gonna say that. So Backbone, Sencha, each of these frameworks doing some sorts of dealing with all kind of architecture problems. But our confidence in these frameworks kind of perished after we did a lot of prototyping, because we noticed that performance can be impacted by anything. So we didn't want to lose touch with the actual DOM and the actual JavaScript. And we didn't have any experience. So also most of these frameworks, like I said, SVG was a dying technology by then. They had poor SVG support, almost none. So one less reason to use a framework. Most of these frameworks were built for usability and extensibility, and at that point, nobody cared so much about performance. And there was not too much wisdom about how to optimize web apps by then. Even Chrome developer tools was not that amazing for detecting performance quirks. So we decided to not pick any framework. We'll just stick to jQuery and jQuery templates for rendering stuff on screen and views, and build our own layout engine, because SVG is positioned in an absolute way. So we built our own layout engine with our own layout vocabulary, very similar to CSS, I guess. And that layout engine would deal with vector reshaping. We didn't want just to scale things, but also to resize them physically. So if you worked with SVG, you know what I mean. So you can either zoom on things and pretend they're this big, or you can reshape them. So if you have, in SVG you have polygons, you have all kinds of things, so you have to write code to resize them physically. Same with measurement and positioning. So after another round of being more lazy and debates about frameworks, we eventually managed to launch something on the web. And like any other person from here, would do, we launched on Hacker News. You guys know Hacker News. So this was basically our launching step. The reception from the public was really amazing. We stayed on the front page for 2 or 3 days. It's not possible anymore, it's too crowded. But for 2 or 3 days, our servers were flooded by our imminent success. And starting from there, we had a lot of favorable press from all over the world, major publications and so forth, writing articles about us, Mashable, SidePoint, and so on. So people were really interested in our technology, and in 2013, we had enough courage to dream about monetizing this. We didn't charge any money for about a year. And this is the initial set of features from the initial mockups. And based on the feedback we got from our users, we decided to add more stuff. Don't bother about reading everything from there, but the gist of it, it's more graphical capabilities, the payment modules, the ability to collaborate in real time, The UI was revamped quite a bit, and so on. And meanwhile, the community saw a lot of potential that we also saw, so they kept asking for more and more features. Add rulers, why can't I rotate stuff? Why can't I zoom? It's SVG, you should be able to zoom. Why can't I crop stuff? So, or resize multiple things at once. Add fonts, whatever. But during this time, we're still doing mockups in our spare time, so we didn't care too much about architecture. And we built a monolith, which turned into a code-based monster that was not maintainable anymore. This is a classic story for any project that has any kind of success. But it was a fast code-based monster. People really loved it because it was probably the fastest app on the web by then from this category. So the key points from here are that if you're paranoid about performance, your users will really appreciate it. It doesn't matter how you do things. For them, speed is of utmost importance. They don't care about React or Reactive or Angular or whatever. They care about performance. And not picking a framework was a double-edged sword. On one side, it ended up in an architecture mess because we had no experience with building web apps, or not too much experience. We had some experience, but not too much. And because we didn't pick any framework, we could get very close to what the browser was doing. So we learned about hardcore DOM and JavaScript optimizations. We would learn that if you do mess with the DOM too much, you would lose performance, so you'd have to batch the operations. You would learn about scrolling performance issues. You would learn about all kinds of things that you tend to get shielded when you use a framework. A framework would probably keep you away from learning the hardcore stuff. And that's really important for your career and if you're building really performant JavaScript apps. And a piece of advice, try not to build over the same pile of crap for too long. It's going to bite you at some point. And about SVG, somebody was asking, SVG versus Canvas, there you go. SVG is really, really fast, and especially in the latest years, is making a comeback. It's not a dying technology anymore. And the browser implementators also added hardware acceleration, and it's getting a lot of love right now. I remember that in 2011, we were looking at the source code for Chromium, the C++ source code, and we saw that the SVG modules were not touched for years. So it was really a dying technology. Browsers were getting ready to get rid of it. But not anymore. It's getting all the love from all the browsers. So with this code-based monster, we said, and we launched the premium version. We're starting to make money. We were employed at our own company, and at some point we said, why don't we start from scratch? And there was silence in the office. Now, this is just for dramatic effect. There was no silence. People thought we're crazy. All of us thought we're crazy. But we realized we had no chance just for implementing rotation and zooming and so forth. We could not use the same jQuery UI widgets for helping us. They were not extensible. They were not made for this. So we decided, okay, we'll start from scratch. There's no pressure. We're still making money. We still have this version. It's very popular. It's growing. So in 2013, we decided to start the new mockups. So the objectives were quite simple. Get rid of the monoliths and the God objects, and ditch jQuery and jQuery UI because they turned out to be the biggest performance drags. Try to use a pub/sub event bus, so components, modules could communicate between each other. We would have proper state management, and we would abstract the SVG and HTML usage as much as possible. and maybe get back to the fun part and evaluate a framework again. So I'll just get back to, I'll just skip to this part. In 2000, so you see, we were lazy. I was just talking about 2013, and we're now at 2014. So this is progress. We made this much progress by then. No, I'm kidding. We had to maintain the old app, fix bugs, and so on. So we didn't have too much development capacity. In fact, only one or two of us could actually seriously think about rebuilding mockups from scratch. So React, in 2014, it's like looking 10 years ago. A lot of things changed since then. So React was still in its infancy. It was making a lot of buzz, but not too much. The tool chain that we're using was really complicated. It was really hard to start with React in the past. It was not really easy. And React didn't have any poor SVG support. Had very poor SVG support. But it had this interesting technology which was important for us, which is called virtual DOM. Virtual DOM, basically you have your own very fast DOM version in the memory, and you can only apply the differences between what changed from a state to another. And it was really interesting for us because we knew that the new mockups would require much more performance. So we had to squeeze it from somewhere. That's why we didn't include Angular in our evaluation, because Angular back then had no virtual DOM support. So it was out of the question. And there was also this anonymous library called Reactive with a very annoyingly confusing name. It's a very similar name, Reactive React. But it was built with SVG in mind. It was made by the journalists and the data visualization team at The Guardian. So they would use Reactive for building fancy visualizations like you've seen before, and infographics and charts, and it was really, really fast. And they would really give SVG the love it deserved. And it was really easy to use. You had no toolchain. There was no ES6. ES6 was really immature by then in terms of implementation, the transpilers and so on. You would really have a lot of bugs and performance degradation. And the nice thing about Reactive, because we were still paranoid about performance and keeping touch to reality, it was not very opinionated. So basically, there was a bunch of guys that learned about JavaScript design patterns and implemented them. So you had observers, decorators, and helpers and so forth. Very straightforward. Nothing very opinionated, so you cannot go back from it if it turns out it's a bad idea. And it also had the support for this interesting technology called virtual DOM, which was enough of a reason, and it looked a bit more light and more under control. So we picked Reactive instead of React. Again, React was not very, looked scary, to be honest. It looked really, really scary. Even now it looks a bit scary, but yeah. So we settled on Reactive. I said Reactive, right, okay. So we went with it. And after that, we had new unknowns. Even if we were using SVG since so long, we said, how are we going to zoom stuff? And more importantly, our users kept pushing us toward making mockups a more advanced design tool. So we had to have rotation. We had to have rotation. So we didn't know how to build something that you could rotate on screen. So stuff like this. I just had to do that, so there's no way to explain it. So you take something and you rotate it, and then you modify it like the way you want. You've seen this in any kind of graphical editor. It turns out it's not as straightforward as you want it to be, because it sucks when you skipped all the math lessons in the high school and you know no algebra or little algebra and trigonometry and so forth. So I had to relearn everything from scratch, so build this freaking prototype. But things get very complex because you work on multiple layers. You draw those resize handles on the upper layer, and the SVG graphic is on another layer, which is zoomed, and the object itself is rotated. So you have to convert a lot from one space to another. You have global space, the viewport space, and the object space. So you'd have to juggle with them, so you know where it snaps and so forth. But we eventually did it, and not only we did it, we also had to make this work for multiple objects. So it would rotate multiple objects, and we learned a lot about how to properly use matrices and convert between global space, local space, and object space. It's still not easy. We're still looking at ways to implement this, but luckily we had SVG point and SVG matrix, these classes, to give us an insight on how to do things. There were not many examples about how to do these things on the web. Even Stack Overflow, you would look at something, it was so frustrating. There was nothing in there, except maybe a few open source projects like SVG Edit had some of these things, but their code is absolutely a disaster. We even resorted to looking in the C++ source code of the browsers to see how we can decompose matrices, because they had it in C++, and eventually we had to port it to JavaScript, so we can extract rotation and scale from matrix. Anyway, so we solved this eventually. It was kind of a most challenging part in Mocha, how to deal with these kind of things. And eventually we ended up with an architecture like this. I'm not going to go into details, it's too much. But this kind of architecture allowed us to move really, really fast with implementing whatever was in Moqups 1 and a lot more things that our users asked from us. So this way, Moqups 2 becomes a pretty advanced design tool. You could crop, you could apply drop shadow, you could do whatever, pretty much what you can do in Illustrator, but at a very simple level. And on top of this, we also have to build stuff like animation. So maybe one day you'll use Moqups for creating your stuff. And animation, more advanced prototyping, and also we're working on diagramming. So it turned out that all this series of decisions we've made paid off. Looking at the evolution of React right now, we kind of feel envious, because we want to play with the same toys as the rest of the world. But if you look from a pragmatic angle, in the end, what matters is what's the best decision for your product, not stimulate your developer ego. So this was a very good lesson for us. And the nice thing about the fact that we used a very non-opinionated framework was that we could use Reactive and React in parallel without any kind of conflict. So we actually plan to do this. We plan to slowly convert mockups into React. But maybe not. I don't know. These frameworks come and go. Every year there's a new flavor. So for an app as complex as mockups, it paid off that we didn't have any flavor. So Mockups 2 had a lot of more features, like I said, you had page zoom. We managed to achieve whatever we wanted with editable nested groups, rotation. I think Tom worked at something similar for Apple. And I know this because there were only few players in the industry doing this kind of thing. Apple, Google, and maybe a few others. But you really had to be crazy to start a graphical editor on the web back then. So we had all these things, and the nice thing about our rewriting everything from scratch and thinking about architecture, we were able to deliver this really, really fast. And fast means about a year and a half or two, but it's fine. All right, so that's pretty much it. Thank you.